Good morning, student. In last lecture, we discussed unit cell. That means types of unit cell, primitive unit cell, and center unit cell. Also, we discussed how the unit cell can be identified. The unit cell can be identified by 6 parameters: A, B, and C, which is known as axial distance, otherwise edge length. Again, angle between them, that means alpha, beta, and gamma. By these 6 parameters, we can identify unit cell. Again, we discuss crystal lattice. Crystal lattice, otherwise space lattice. That means regular three-dimensional arrangement of the constituent particles, that means atom, molecules, or ions, which is known as crystal lattice. So there are 14 types. There are only 14 possible. Three-dimensional lattice are there. 14 types. That means 14 types of various arrangements are available, and they are called Bravais lattice. That means numbers of Bravais lattice are 14. So we have to calculate the 14 Bravais lattice. Before that, we study the various crystal system, and later on we calculate 14 types of Bravais lattice. Now unit cell. Unit cell can be characterized by these 6 parameters: A, B, C, and alpha, beta, and gamma. A equal to B equal to C. Otherwise, alpha equal to beta equal to gamma. They are perpendicular, not perpendicular. A, B, C. Bond angles, otherwise angles are same, not the same between them. Based on this crystal system can be classified into 7 categories. So these 7 categories are: the first one is cubic system, second one is tetragonal, third one is orthorhombic, fourth one monoclinic, fifth one triclinic, sixth one is rhombohedral or trigonal, 7 is hexagonal. Now these are the basic 7 systems. How to identify these 7 basic systems? Based on these 6 parameters: A, B, C, alpha, beta, gamma. Now edge length or axial distance and axial angles, they are known as axial angles. So in cubic system, A equal to B equal to C, alpha equal to beta equal to gamma equal to 90, then it is cubic system like this. A, B, and C. Okay. So here A equal to B equal to C. Again, these 3 angles, that means alpha, beta, and gamma, all are 90-degree equal. This type of system is known as cubic system. And examples are found NaCl, zinc, lead, and copper. Just remember example. Now second system is tetragonal system, in which A equal to B but not equal to C. That means A and B are equal, C is not equal. But alpha, beta, gamma equal to 90-degree. Such type of system is known as tetragonal system. Examples are white tin, SnO2, PiO2, CaSO4, that means calcium sulfate. Now third system, orthorhombic. How to identify? So A is not equal to B, not equal to C. Alpha, beta, gamma equal, and they are 90-degree. Examples: rhombic sulfur, potassium nitrate, and barium sulfate. Monoclinic, fourth one is monoclinic. Monoclinic, so A is not equal to B, is not equal to C, alpha gamma equal to 90 degree, beta is not 90 degree. Remember, monoclinic sulfur, sodium sulfate in hydrate form, that means decahydrate, is the example of monoclinic system. Now fifth one is triclinic. Triclinic means A is not equal to B, is not equal to C, alpha, beta, gamma equal to not equal to 90 degree. That means triclinic is completely opposite to cubic system. In cubic system, A equal to B equal to C, alpha, beta, gamma 90 degree. Here triclinic is completely opposite. That means cubic system can be easily converted to triclinic. Potassium dichromate, example, copper sulfate in hydrate form, H3BO3, that means boric acid, otherwise we can say orthoboric acid, is an example of triclinic system. Now sixth one is rhombohedral or trigonal. So A equal to B equal to C, but alpha, beta, gamma equal, but they are not 90 degree. A equal to B equal to C, but alpha, beta, gamma is not equal to 90 degree. Examples, calcite, that means calcium carbonate. Calcium carbonate is available in various forms, from which calcite. Again, second example, HGS, mercury sulfide, famous name is cinnabar, having the system like rhombohedral or trigonal. Now 7 is hexagonal. Hexagonal, we know very well, A equal to B, but not equal to C, alpha, beta equal to 90 degree, and gamma equal to 120 degree. Examples are graphite, zinc oxide, cadmium sulfide. These are the information given in textbook. Remember, now our aim is to decide the 14 types of Bravais lattice. So these are the simple 7 types of system are available. Now, in which possible variation are there? That means this is cubic system, okay, in which primitive, body center and phase center. That means cubic system is there. This is cubic system. Okay, in which there are 3 types of variation are possible: primitive, body center and phase center. That means primitive means constituent particles are present at corners. This is primitive variation. Body center means constituent particles are present at corners. Again, additional constituent particles are there, which is present at body center. So additional particles at body center. And phase center means constituent particles are present at corners, okay, as well as face center. That means left side, left face, right face, top, bottom, and front side and back side. That means extra 6 particles are required. That means here 3 types of cubic system is there, but primitive, body center and face center. So here three possible variations. In case of tetragonal, only two possible variations. Primitive, that means corners plus body center, so corners plus at the body center. So here two variations are there. Similar way in case of orthorhombic, 1, 2, 3, 4. All four types of variation are there. And center means we know very well. Two extra particles are present at the center of two opposite faces. That means and center. Again in case of monoclinic, two possible variation. That means two. In case of triclinic, rhombohedral and hexagonal. Only one and one. No possible variation. So if we add 3 plus 2, 5 plus 4, 9, 11, 12, 13 and 14. So 14 types of Bravais lattices are there. Actually basic system are 7. This time 7 crystal system is there. And possible variation, then it becomes 14. Now we can see observation in triclinic, rhombohedral and hexagonal. Only primitive unit cell is possible, no variation is possible. Remember, in case of orthorhombic, all four possible variations are there. Remember, in which crystal system four types of possible variation are there. So only in orthorhombic system. In cubic system, three types. Here only in cubic system, three types of variation are there. So they are asking sometimes, in which system only three types of possible variation are there. So only in cubic system. And in tetragonal system and in monoclinic system, there are two types of variation are there. So by this way, we can calculate the 14 Bravais lattices. That means our aim to identify 14 Bravais lattices is completed. I think the topic will be clear for you. Thank you.